described by monomolecular theory. Adsorption as process is described by monomolecular theory. It was formulated in 1916 by Erwin Langmuir. So, adsorption as process is described by the monomolecular theory. It was formulated in 1916 by Erwin Langmuir. Now let's describe the general position of the monomolecular theory. The first position is adsorbent surface contains active sites. So active site is area with exact my microphone is working. So adsorbent surface contains active sites. Active site is area on the surface that has excessive in energy. The next position. Each adsorbate molecule may occupy only one active site. Each adsorbate molecule occupy only one active site. The next position. Adsorbate molecule doesn't interact with another molecule that are surrounded it. Adsorbate molecule doesn't interact with another molecules that are surround it. The next position. Adsorption occurs until moment when monomolecular layer forms on adsorbent surface. Adsorption occurs until moment when monomolecular layer forms on adsorbent surface. Monomolecular layer is reversible state. Two opposite processes take part at this moment. Monomolecular layer is reversible state. There are two opposite processes take part at this moment. Some amount of adsorbed molecule leave adsorbent surface and they are replaced by another new adsorbate molecule. So adsorbed molecule leave adsorbent surface, and at the same moment they are replaced by new adsorbate molecules. So, and as a result, there are two opposite processes take place. The first is desorption, it means leaving surface, and adsorption, it means accumulation on surface. So monomolecular layer is a reversible state, and there are two opposite processes. Happens at this moment. Desorption, it means leave adsorbent surface, and absorption, it means accumulation on adsorbent surface. Dependence between adsorption and adsorbate amount is expressed by Langmuir isotherm. Dependence between adsorption and amount of adsorbate is expressed by Langmuir isotherm. So Langmuir isotherm is graph that shows dependence between adsorption value and adsorbate concentration. So when adsorbate concentration is low, adsorbate value increase. During some time, adsorbate value becomes constant and doesn't change. When concentration of adsorbate is low, adsorption value increases. When adsorbate concentration is low, adsorption value increases. When adsorbate concentration is high, adsorption value is constant and doesn't change. Adsorption value is constant and doesn't change when adsorbate concentration is high. It's explained It's explained the following fact that all active site It's explained the following fact that all active sites are full in adsorbate molecule and monomolecular layer forms. It's explained the following fact that all active sites on adsorbent surface are fooled by adsorbate molecule and monomolecular layer forms. Adsorption are divided in two types. Adsorption is divided in two types, physical and chemical. When physical adsorption occurs between adsorbate and adsorbate, adsorbent and adsorbate, there are physical interaction. It may be interaction like to like or van der Waals forces. It may be hydrogen forces, or it may be weighting as a physical phenomenon. So when physical adsorption occurs between adsorbent and adsorbate, physical interaction happens. It may be interaction like to like or van der Waals. It may be hydrogen forces, or it may be weighting phenomenon. Physical adsorption is exotomic process and it is a reversible phenomenon. Physical adsorption is exotomic and a reversible process. And as a result, it is provided by low temperature. Physical adsorption is provided by low temperature. When chemical adsorption happens, adsorbate is kept at adsorbent surface by chemical bond. So between adsorbate and adsorbent, chemical reaction happens. It is endatomic process. It is endatomic and irreversible process. That's why it is provided by high temperature. Adsorption occurs at different heterogeneous system, and we will describe adsorption process on movement borderline or liquid. So we will discuss adsorption at the borderline between liquid and gas and liquid and solid surface. It happens because our inner sphere is liquid. So adsorption on borderline between fluid and gas. Adsorption on the borderline between fluid and gas. So liquid as borderline has excessive surface energy. Excessive surface energy for liquids. Excessive surface energy for liquids is described by surface tension. Excessive surface energy for liquid is described by surface tension. Is signed as Greek letter sigma. So surface energy in liquid, will change. Surface energy for liquid will change when some dissolved substance will appear. Surface energy for liquid or surface tension of liquid will change when some dissolved substance will appear in liquid. That's why we use term surface activity as dependent between amount of dissolved substance and surface tension value. Dependence between change in amount of dissolved substance and surface tension for liquid is called surface activity. This term is on slide. So surface tension is some excessive energy for liquid. So there are three groups of substance. There are three groups of substance. First is surface inactive substance. Surface inactive substance. Surface inactive substance increase. Surface inactive substance increase surface tension for liquid. All electrolytes are surface inactive substance. For example, potassium iodide, sodium chloride, sulfuric acid, and other. So surface inactive substance increase surface tension. All electrolytes are surface inactive substance. The second group is surface non-active substance. surface non-active substance. They not change, they do not change surface tension. Surface non-active substance do not change surface tension for liquid. So different gases, for example, oxygen, nitrogen, methane, propane, and some organic substance like glucose, sucrose, fructose are surface non-active substance. They do not change surface tension. And the last group is surface active substance. Surface active substance decrease surface tension value. Surface active substance decrease surface tension. Dependence between amount of dissolved substance and surface tension for liquid is called surface tension isotone. Dependence between amount of dissolved substance and surface tension value is called surface tension isotone. This graph you can see on slide. So please rewrite it at your notebooks and I will comment. So undependent value is signed on horizontal line. It's amount of dissolved substance. On vertical line, dependent value is signed. So, and we see there are three groups of substance that change surface tension for liquid. For example, for water. For pure water, surface tension is equal about 75 kilojoule per square meter. So surface inactive substance, or CIS, surface inactive substance. They increase surface tension value. Surface non-active substance, or CNS, do not change surface tension of water. And the third group decrease surface tension of water. So decrease in surface tension means decrease in surface energy, decrease in surface tension means decrease in surface energy. That's why surface active substance accumulate on the liquid surface. Surface active substance accumulate on the liquid surface. So which class of substance do surface active substance correspond to? So which class of surface active substance do substance correspond to? So surface active substance are organic substances that have diaphilic structure. Surface active substances are organic substances that have diaphilic structure. Their molecule include hydrocarbon non-polar tail, or radical, and polar head that is formed by different functional groups. Surface active substances include in their structure hydrocarbon non-polar tail or radical and polar head that is formed by different functional groups. These functional groups can form charge, and it may be hydroxyl group, amino group, sulfur group, carboxyl group, and phosphate group. That's why surface active substance is signed as round, it means head, and line, it means tail. So once again, surface active substance are organic substance with diaphilic structure. They include hydrocarbon nonpolar tail and polar head that is formed by different functional groups. Functional group in organic compounds can form charge. It may be partial or full. So head may be formed by the following group: OH, NH2, sulfur group, carboxyl group, and phosphate group. So all organic substances that include nonpolar hydrocarbon radical and some functional group are surface active. So what happens if surface active substance will appear in liquid? When surface active substance enter to liquid, for example water, it will stay at the borderline. So water is polar and surface active substance can't diffuse into liquid because it has non-polar part. So that's why surface active substance will stay at the borderline. Surface active substance will stay at the borderline and orient by polar head to water and non-polar tail to air. So when surface active substance is entered into liquid, for example water, it can diffuse into volume because it has non-polar part. That's why it will stay at the borderline. Surface active substance will orient by polar head to water and non-polar part to gas. During some time, all surface of water will covered by surface active substance molecule. During some time, all surface water will covered by surface active substance molecule. This state is called monomolecular layer, Langmuir palisade, or limited adsorption. It is stable state. Because polarity between phases decreases. This state is stable because polarity between phases decreases. So gas or air is non-polar because it contains oxygen and nitrogen, and water that is covered by non-polar tails are non-polar too. So adsorption on the borderline between liquid and gas is described by Gibbs equation. Adsorption on the borderline between liquid and gas is described by Gibbs equation. Adsorption is signed as Greek letter gamma. So T is temperature that is expressed in Kelvin. R is universal gas constant. And the last component is surface activity. Surface activity substance differ in their ability to adsorption. Surface active substance differ in their ability in the ability to adsorb on the surface. It is described by Trober and Dakla rule. Surface active substances differ in their ability to adsorb on the liquid surface. It is described by Trober and Dakla rule. So it says that elongation of radical on each homological difference elongation of radical on each homological difference or CH2 group leads to decrease of surface tension at free or free and half time. Elongation of radical on each homological difference or CH2 groups leads to decrease of surface tension at free and free and half time. So, for example, we have two alcohols, methanol and ethanol. So they have the same chemical structure, but ethanol has two carbon atom in radical and methanol has one. If we compare change in surface tension, we see that ethanol decreases surface tension value in more time compared to methanol. So ethanol decreases surface tension value in more time compared to methanol. It means that ethanol adsorbs better compared to methanol. And if we compare any other substance that will have the same chemical structure, we will have the same figure. So as longer radical, as lower surface tension value. Now let's discuss adsorption at the borderline between liquid and solid material. Adsorption at the borderline between liquid and solid means change of amount of dissolved substance on the surface of solid material that is expressed in gram. So adsorption at the borderline between liquid and solid means change in amount of dissolved substance on 1 unit of solid material. So it may be expressed by the following equation. Adsorption from solution is divided in two types: molecular and ionic. Adsorption from solution is divided into two types, molecular and ionic. Molecular adsorption is adsorption of non-electrolytes or weak electrolytes from their solution on solid surface. Molecular adsorption is adsorption of non-electrolytes or weak electrolytes from their solution on the solid surface. It based on physical phenomenon that is called wetting. Molecular adsorption is based on the physical phenomenon that is called wetting. So when some liquid wets solid material, it means that it spread over surface and forms thin layer. That's why we can say that physical phenomenon wetting is equivalent to adsorption term. As we know, polar liquid wets polar solid material and non-polar liquid wet non-polar solid material. According to this rule, Soviet chemist Petr Rebinder formulated the following rule. As worse solvent wets adsorbent surface, so better dissolved substance will adsorb. As worse solvent wets adsorbent surface, so better dissolved substance will adsorb. Or in another word, polar dissolved substance will be adsorbed better on polar surfaces, and non-polar dissolved substance will adsorb better on non-polar solid surfaces. So how can we define polarity for any object? Polarity of any object depends on their structure. Polarity of any object depends on their structure. Substances with weak polar or covalent non-polar chemical bond are non-polar. Substances with weak polar covalent bond or non-covalent non-polar covalent bond, weak polar or non-polar covalent bond are non-polar. Substances with ionic or covalent polar bond are polar. substances with ionic or covalent polar bond are polar. So that's why we can divide all liquid and solid material into polar and non-polar. So polar solvents are water that has covalent polar bond H between hydrogen and oxygen, and all alcohols because they contain OH group. Non-polar liquids are benzene, gasoline, and liquid hydrocarbon, for example, hexane. What about solid material? Polar solid material are silica gel or solid silic acid, cellulose as polysaccharide with OH group, talc that is represented as magnesium silicate, clay, or iron-free oxide or iron-free hydroxide. Non-polar solid material are coal or carbon and different solid hydrocarbon, for example, paraffin or polypropylene. So how can we use Rabindra rule for selection liquid? For example, we must select colorants from vegetable oil. So what type of adsorbent must be chosen? So at first, we must define nature of dissolved substance. So oil or liquid fat is non-polar. It may be determined because oil is not dissolved in water, or it may be determined according to the chemical structure. Polar functional group is absent in liquid fats because they are esters, and different polar group OH or COOH is absent. Colorants are organic substance that has non-polar hydrocarbon radical and polar functional group. That's why colorant is diphilic substance. So adsorption from solution is based on wetting phenomenon. So non-polar liquid better wet non-polar solid material. Polar liquid better wet polar solid material. And if we need to remove substance that content polar part, we must choose polar solid material. If we choose non-polar solid material, it will wet. It will wetted by as oil as colorant, and as a result, liquid are not deleted. So if we choose polar solid material, diphilic colorant will be deleted from mixture, and it will orient by polar head to solid material and non-polar tails into solution. As a result, if we choose polar solid material, substance with polar part in their structure will be deleted from solution completely. Only oil will stay at solution. It can be expressed by the following scheme. At initial step, we have mix in non-polar liquid and liquid in with diaphilic structure. If we choose polar solid material, only diaphilic component will accumulate on solid surface. It will orient according to principle like to like. Polar part will orient to polar solid material. Non-polar part will orient to non-polar liquids. And as a result, it will cover off solid material completely. So the next type of adsorption from solution is ionic adsorption. Ionic adsorption is adsorption of strong electrolytes from their solution on polar solid surface. Ionic adsorption is adsorption of strong electrolyte from their solution on polar solid surface. Strong electrolytes are represented as ion in their solution, and they dissociate completely. Ionic adsorption is adsorption of strong electrolyte from their solution on polar solid surface. Ionic adsorption is divided into selective and exchange ionic adsorption. Selective ionic adsorption is adsorption of specific ion from solution on solid surface. Selective ion adsorption is adsorption of specific ion from their solution on solid surface. It surrenders to Fayence and Panet rules. It surrenders to Fayence and Panet rules. The first rule says that ions that can complete crystal lattice of solid surface will adsorb on their surface. Firstly, ions that can complete crystal lattice of solid surface will adsorb on their surface. Firstly, for example, we have heterogeneous system that is represented by solid barium sulfate and mix into solution barium nitrate and potassium nitrate. Electrolytes are dissociated and as result, barium, nitrate and potassium ions are represented in solution. According to the first rule, only barium ion can adsorb on solid surface because only barium ion can complete crystal lattice of barium sulfate. Barium ions will cover solid surface completely and as result it will become positively charged. Ions that adsorbs from solution firstly are called potential determinant. Ions that adsorb from solution at firstly are called potential determinant. Potential determinant ion. So barium ions are potential determinant. The second rule says that charged solid surface will adsorb those ions that has opposite charge compared to it. Charged solid surface will adsorb those ions that have opposite charge compared to it. So continue to discuss our previous example. There was barium sulfate in solid state and above it was mix from two salts, barium nitrate and potassium nitrate. We said that barium ion was adsorbed firstly. So, and as result, solid surface becomes positively charged because barium has positive charge. And as result, only negatively charged ion will be attracted to solid surface. Nitrates ion have opposite charge, so they will attract to barium ions. And as a result, double layer from ion will form. The next type of ionic adsorption is exchange ionic adsorption. I'm sorry. 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 So exchange ionic adsorption. Exchange ionic adsorption. It is type of adsorption when ions from electrolyte are exchanged. Ions from electrolyte are exchanged on the same charged ion from solid surface. Or in other words, ionic exchange adsorption is adsorption when ions from electrolyte exchange with ions with the same charge from solid surface. Solid materials that can exchange ions are called ionite. Solid material that can exchange ions is called ionite. So compared to type of exchange ions, there are catianite and anianite. So all ionite are organic polymer. In their crystal lattice, they contain chemical connected functional group and free ions that can be exchanged on another ions from solution. Catianite contains positively charged particle that can be exchanged. Anianite contains negatively charged particle that can be exchanged on ions from solution. So, for example, if we pass through solution through catianite, exchange in positively charged particle will happen. So catianite at scheme is expressed by the following scheme. So vertical line, that means solid material, then carboxyl group that forms strong covalent bond with polymer, and some positively charged ion, for example hydrogen, that can be exchanged. And when we pass through sodium chloride solution, one positively charged sodium ion will be exchanged on one positively charged ion from solid material, and as a result hydrogen ions will accumulate on solution. So ions are exchanged at the same amount and at the same charge.